follow up, isn't it? I have a video. No, it's not. Like, how do you follow that? Like, there was some serious production value, on that. Spielberg was busy. He was able to give us some time to get that one going, which is very, very nice of him. All right, perfect. All right. Cool. Great. So maybe not the smoothest transition, but thank you, everybody. My name is Marty Gubar. I'm from the product management group at Oracle. And, okay, so now here's my video. Okay, so I don't know how many of you are paying attention. Yesterday, Larry made a big announcement for Oracle, which was our in-memory option to the Oracle database. And that's really just the beginning. We have a lot of announcements that are coming, and here is another. Do we have volume?
MapReduce code, or even something else. And how do you join those results with existing enterprise data? What if you could just use the SQL you know? Write a single SQL query, even when the data is distributed across both Hadoop and your data warehouse. And you wouldn't even have to know which data was in which platform. Reuse the SQL skills that you already have to get value from big data.
All right. Thank you, everyone. Thank you. That's our video. About 30 seconds. That's all we could afford. So I'm actually going to provide some more context from what you just saw in that 30-second video. So we're going to have the announcement, as you know, please, I guess around 1 month from today, or 1 month from, I guess it's July 15th, we'll have another big announcement, as you saw. And it's around our big data management system. Now, there's really 3 themes that we're trying to deliver on to help our customers really gain value and really exploit all the value from big data. The first theme is to simplify. Right? We want to be able to simplify access to all your data, no matter where that data may reside. It might be in a Hadoop cluster, it may be in a NoSQL store, or it may be in your Oracle database. So simplify. The second thing is to be able to analyze all that data, and analyze that data with the best performance possible. And the third theme is to be able to secure and govern all that data. Again, whether that data resides in the database, the Oracle database, whether it's in Hadoop, HDFS, or if it's in SQL, Oracle database, wherever it is, we're going to be able to secure and govern all of that data. So as I go through this big data management system, we're going to be talking about some new capabilities that we haven't yet delivered. And it's upcoming. So, of course, we have our safe harbor statement. So today, customers are really gaining a lot of value from big data and our big data platform. I've just picked out 3 customer snapshots. These are companies that have just recently purchased and implemented our big data platform just in the past year. Right? So it's actually been a great year for big data and our big data platform. The first is a massive consumer packaged goods company. And these 3 examples that I'm going to go through are actually very different use cases, and that's why I pulled them out. We have many that we could potentially go through here. But the first is this really large consumer goods company. And what they've done is they've actually implemented a data science organization within the company. And they contract out to other groups within the business. Right? And what they're attempting to achieve is, again, they want to be able to access, and this is a company that's very data driven. I mean, I've been working with this company for 20 years, right? Whether they're using multidimensional technology, Oracle database technology, whatever. They've been working with Oracle for some time. And so they have this data sciences organization that's attempting to solve different problems across the business. Whether it's better understanding product rollouts, better understanding marketing spend, whether it's customer-facing, consumer-facing, research and development type of applications, they're applying big data technologies across the organization. And this one group is really, they've centralized it, and they contract out across the business. The second is a very large, one of the largest Spanish banks. And like many banks, right, there's been lots of consolidation. They have customers accessing the bank through many channels, whether it's ATMs, mobile, web, et cetera. And a lot of that data is locked up in mainframes. Right? So what they want to do is, what they've done is they've created a data pool. And they're pulling data off of that mainframe. They're unlocking that data that's trapped in the mainframe. They're putting it into this data pool. And now they're able to see a single view of the customer, regardless of the touch points, regardless of how they're accessing and working with the bank. They're better able to understand who that customer is, and they're better able to make valuable offers and provide valuable services to those customers. So they've collected and they're unifying data across the organization, across these different systems. And the third is yet another completely different use case, which is a small gaming company. Right? And they're collecting all of the clicks, all of the user interactions from their games. And they just want to provide better games. Right? They want a more compelling user experience for their customers. So better understand the customer usage, produce better games. So interestingly, in each of these situations, they're expanding their data footprint. Right? They're expanding it both on the big data side, Hadoop, NoSQL side, as well as on the relational side. Right? In each of these cases, they're actually using our engineered systems. So we have an engineered system for big data. We have an engineered system for the database. We actually have a couple for the database. So we have something called the Big Data Appliance. And they're using Exadata. And they're bringing these two systems together. Right? And what they want is they want to be able to seamlessly work with data regardless of where it lives. It doesn't matter if it's in the database. It doesn't matter if it's in Hadoop. They want they want seamless access to all of that data and merge all of that data and analyze all of that data together. I mean, that's the goal for each of these customers. And I'm from the development group, and that makes some challenging requirements, and that's what our mission has been, is to simplify all of this and to make it easier for these customers. So, it's a slightly tangled web, right? And if you look at it, Hadoop is good at some things, and databases are really good at others, right? I love this spider chart. So basically, if you look at here, if you look at the database is like really rich tooling. I mean, there's thousands and thousands of products that can exploit relational databases, whether it's applications, tools, et cetera, right? There's ACID transaction support. There's very rich security models. Backup and recovery, all of that is just commonplace and standardized in the database is really, really good at that. That's why you have all of your valuable data in relational technology today. While Hadoop and NoSQL, in many ways, is oftentimes complementary, right? So Hadoop is very good at capturing different types of data formats, whether it's JSON, XML, images, whatever, right? It's just capturing files. So it's very easy to capture any type of data format. It's good at handling sparse data. It's cost effective, right? It's easy, it's relatively inexpensive to scale out your applications with Hadoop and with NoSQL, right? So there's strengths for each, right? And the question is, how do you take advantage of both, the strengths of both? Also, if you think about the Hadoop ecosystem, there's been unbelievable innovation. Think about this. Like, where were we like 5 years ago? Right? It barely existed, right? And Google did a good thing, right? They say, hey, we've got to index the internet, and it's a hard problem. So what we're going to do is we're going to create a scalable infrastructure that makes it easy to, you expand your storage and you expand your processing ad infinitum. You can make this infinitely scalable. And that's what they've done to index the web, right? And that's what Hadoop brings to the table. And as part of that, there's the Hadoop file system, which is core to this. And then, it started with the MapReduce paradigm. Right? So MapReduce is the processing framework that enables you to analyze all of this data and process all of this data in a cost-effective way, right? And when it started, let's go 6 years ago, Java, you used low-level Java APIs to take advantage of Hadoop, right? It was fairly complicated. You really had to understand the processing under the covers. It is a challenge. So of course, there's been innovation, right? And one of the big innovations was something like Pig. Great names. We had things like Oracle NoSQL database. Actually, it's funny. Our NoSQL database team, their name was going to be Catania. And Larry makes all the decisions for product names. So Catania is I think it's like a Japanese warrior. And Larry has a boat, and I think it was called Catania, and they thought, oh, we're in. We're going to call this Catania. Because, you look at Hadoop, you have MapReduce, and you have Hadoop, and you have Pig, and Hive, and all this. So we're Catania. And, of course, Larry goes, well, what does it do? What is this thing? It's a NoSQL database. So Larry's like, okay, Oracle NoSQL database. And it's kind of boring, but that's kind of how we roll. Anyway, I digress. So MapReduce, these lower-level APIs are complicated, right? So new technologies emerged, like Pig. So now you have a scripting language, right? So you can use, using simple process flows, you can now take advantage of this data. So you could port or rewrite your code from Java and take advantage of this new Pig capabilities in scripting. Now Spark is available. In-memory processing across your cluster. Even better than before, right? Much faster. Probably an order of magnitude faster, we're finding, for many of our analytic workloads. So what you can now do is rewrite your Pig scripts and your Java API scripts for MapReduce and move it to Spark, right? And now it's an order of magnitude faster, and that's really good. So you get this great innovation that's happening in this ecosystem that you really, really want to take advantage of, right? There's tremendous value there. But there's challenges, right? There's challenges with innovation. And it starts, frankly, with the Hadoop cluster itself, right? So effectively, what customers had done in the past is they rack and stack servers, right? And they then optimize the implementation of those servers, whether it's Linux kernel parameters, Java parameters. There's thousands of configuration parameters for your Hadoop implementation. There's a lot of stuff you can configure to optimize that. So effectively what ends up is that each customer, each deployment is a unique implementation, right? And that's, frankly, a challenging thing to support when there's no two clusters that are alike. So from the operational side, clearly there's opportunity to improve that. And then on the language side, it's terrific that we have all these great new languages, but there's a skill set gap. Right? There's not enough people who can really take advantage of this. And that's an opportunity to solve the problem, right? And there are things that we can do to simplify. So as a result, you have all of this potential, but there's still a gap, right? There's still a gap. So the ability to take advantage of all of this data has not yet met the opportunity, right? So we're producing way more data than we can necessarily take advantage of. And our goal is to reduce that gap. So we have this immense opportunity, and we're not quite there yet. We want to help you get there, right? That's our goal. So the question is, how do you turn that tangled web into something more complete? How do you take advantage of all of the innovation of both the relational technologies and the new Hadoop ecosystem and NoSQL ecosystems? How do you build something like this, and how do you take advantage of this? How do you interact with that system? Well, what we're doing is we're unifying the platform. Okay, so for Oracle, we're using engineered systems to unify these platforms. Right, so we have an Oracle Big Data appliance, and we have Oracle Exadata, right, for the database. So we have these engineered systems for both the database and for the BDA. And what we've done and what we're doing is we're unifying languages, right? So you can have a single language when you need to analyze data regardless of where it may live. And frankly, we're also embracing all of that innovation. If you want to use Spark and you want to use MapReduce, you want to use all these technologies, you should use it, right? You can use any of the new technologies that you want, but if you want to expand the footprint within the organization and really leverage the skills of the folks in your organization, you have new options, right? So we're really just adding. We're not taking anything away. We're not removing any capabilities. We're just adding capabilities so you can take advantage of all of that. We're going to unify the security. We're unifying the security framework. We're unifying administration, single point of support. And eventually we're going to get into things like workload management, lifecycle management, and availability. So stuff is coming. But we're going to embrace that innovation, and we're integrating the big data and the database platforms to create a single integrated platform. So we have a lot of experience in this, right? So Exadata, we released that in 2007, right? And there was tremendous innovation there. One of the things about having, building hardware and software is that you can make it so that they can work better together, right? So what did we do with Exadata? Well, what we did is we moved a lot of the processing close to the data. So in other words, when you're querying the data, when you're filtering and applying functions and stuff like that, we do this at the storage tier. We do this at the disk level, right, the storage tier. And this greatly improves throughput. It greatly improves performance, right? So we're doing scanning and filtering and working data at the data tier. We also index. We have what's called storage indexing. So if you have 50 terabytes worth of data, in order to satisfy a query, we may only have to scan 1/10 of that because we have storage indexes in there. So you reduce scans. And then you can leverage all the advanced security of the database. We've made it easy to upgrade. We've greatly enhanced network protocols, et cetera. So we had this engineered system for the database, which effectively customers could then implement at their sites, and they literally consistently see easily an order of magnitude performance improvement without any changes to their applications, right? And that's critical, right? No changes to the applications. So we took that same methodology of an engineered system. We said, well, let's apply this to big data as well, to Hadoop and to NoSQL. So we created a big data appliance. So out of the box, you get things like enterprise management. So a single enterprise management across your data ecosystem, whether it's in Hadoop, whether it's in NoSQL, or whether it's in the Oracle database. Right? So you can use Oracle Enterprise Manager now to manage that all of your data. Right? Hadoop is not necessarily known for security. Right? Google, indexing the web didn't require a lot of security. Right? So it was kind of a bolt-on, frankly. So out of the box, what we've done with our big data appliance is we've given you the ability to create a secure cluster with authentication, authorization, and auditing of that data. And frankly, when you're auditing the data, you want to see an integrated view, whether that data is living in the database or it's living in Hadoop. You want to audit all of that data with a single auditing framework, and that's what we've implemented. Right, so a lot of experience creating engineered systems, and we just did this. We're applying that same methodology to the big data appliance. Which brings us to SQL, right? Now we have these great systems that have been designed to work together, they're secured together, they're managed together, and now you want to use the data that's in those systems, right? SQL's a pretty good call. If you think about it, what other languages have stood the test of time, right? We go back, SQL's been a key part of all data, it's of all data systems forever, right? It's hard to think of another language. What else has been around since the 70s? You have Fortran and COBOL, but I mean, this is the language of data. And really the question is why? Like, what is it about SQL that's so great? It's just a simple language. Well, what's kind of interesting about SQL, and happy 40th anniversary SQL, is that this query that we see up here, when you ran this in 1974, and you run it today, it just works, right? It's just way faster, right? So the language has, you can take your applications that you developed 40 years ago, and you can just migrate them forward, and it just works. Things get faster. We say, you know what, we're implementing Exadata, so now we're going to do filtering and scanning at the storage tier. It's now 10 times faster. Same application, just 10 times faster. Now even memory. 10 times faster yet again. You don't change your application, and that's what's really nice. Right? It just gets a lot faster. So it encapsulates complexity, really, right? So the execution engine may get more sophisticated, but your interaction with that data is still the same, right? So it simplifies the work for people who are developing these applications. And again, I pulled the names out, but this is what we saw with Exadata. We have a book, we have like this huge book of customers who've had success with Exadata, and we're looking at, one company 60 times faster, and this is across OLTP applications as well as data warehousing applications, right? So query response time 60 times faster, 30 times faster, 17 times faster, right? Same application, same queries, just better. So SQL on Hadoop, not rocket science, right? There's now a lot of SQL engines available on Hadoop. And frankly, we should thank Facebook, right? Facebook innovated this with something called Hive. So instead of writing low-level Java code to be able to analyze data, Facebook introduced something called Hive, which enables you to write SQL over data that's in Hadoop, right? And it will launch batch jobs, effectively, that go off and query this data. And it can query petabytes worth of data, right? And we've just lowered the bar and made this data accessible. And one of the key things, too, that they did is they created what's a single metadata layer called the Hive Metastore. So a lot of these SQL engines that you see here are leveraging that Hive Metastore. So now you have Hive, you have Impala, you have Shark and Drill. There's all these SQL engines. I don't even know. There's probably tens of SQL engines now on Hadoop. Again, leveraging data that's in HDFS and leveraging typically the Hive Metastore. So this is obvious. Now, one of the challenges, these are new too. So if you look at HiveQL, that's like the SQL language for Hive, it doesn't necessarily have the same level of support that you'll see in Oracle, like in the Oracle database. Right? So you have your basic functions, you have aggregate functions, you have windowing functions, but there's a lot of limitations. And they'll be overcome. Right? I'm sure they'll be overcome over time, but it's just the state of where we are today. Right? If you look at the Oracle, the Oracle SQL language manual, it's probably 1,000 pages long. If you look at HiveQL, it's probably, it's a web page. Right? That's kind of what we're talking about in terms of difference. So it will get there. It's just not quite there yet, or it'll probably get there. Right? So you have kind of a minimal SQL dialect at this point. So what does that mean? Well, when you have a minimal SQL dialect, oftentimes it leads to coding. Right? So let's say you have a stock ticker, right? And you're looking for double bottoms in that stock ticker. So you have a pattern, right? And you're looking for patterns in data. And you want to see double bottoms in a stock ticker because that's an indicator of how low a stock may end up going, right? Well, you kind of fall off the complexity cliff, right? When you want to ask that question when you don't have rich analytics, right? And here, you end up writing hundreds of lines of Java-based user-defined functions. And how many people are going to do that to answer this question? So it's harder, right? So when you have a limited SQL dialect, it leads to a huge complexity barrier. And the security on Hadoop, it's getting better, right? So now in Hadoop, we have the ability to do things like authorize access at the column level. So if you don't want someone to see social security numbers, you can now say, okay, you're not going to see that column at all, right? You can audit data. But you don't necessarily have redaction. You don't have row-level security. That will likely come at some point, but it's not quite there yet. So the security story is still evolving. And the last thing is, you have all of this valuable data in your data warehouse, right? All of your financials, your sales data, all of this data is living in your data warehouse. Yet many of these query engines are only querying the Hadoop side of the world. So it's missing the most valuable data that you have in your warehouse, or in your organization. Right? So what we're looking to do, and what you're going to see, is a single big data management system that lets you query all of that data, secure all of that data, manage all of that data, regardless of where it lives. So what we're talking about here is one fast SQL query on all of your data. And we're leveraging capabilities that we've used in the past, right? Exadata is really smart at scanning data at the storage tier, right? We just saw customers who've seen 60 times performance improvement, 17 times performance improvement, et cetera, right? Because they've implemented this smart scan technology that scans data and filters data at the storage level. Good idea, right? For not just the Oracle database, but other technologies as well. Right, so you can now have one fast query on all of your data, leveraging these capabilities that we've already developed. So tried and true technology that had been implemented at the largest companies in the world. Right, so you get the security of the database, and you get the certainty of the Oracle database. So this is not, the way this has been designed is it's not just going to analyze data that's in Hadoop, but it can analyze data that's anywhere, whether it's in an Oracle NoSQL database, whether it's in Hive or HDFS, whether it's in Mongo or Cassandra or any technology. The way it's been developed is it's pluggable, right? So you can now take advantage and you can now seamlessly blend data from multiple sources. I can join data from the Oracle database with data that's in Mongo, with data that's in HDFS in a single query, and do that securely. So when I say securely, I am going to now be querying the data through the Oracle database. And the Oracle database is the engine that's going to process all of this. Or it's going to, I shouldn't say process it, it's going to manage the processing of all these queries. Right? So now, let's say you want to apply redaction policies. Right? So I'm going to apply redaction over the social security number for a customer. Well, once I apply that redaction policy, it doesn't matter if it's in Hadoop, it doesn't matter if it's in HDFS or if it's in Mongo or if it's in Oracle NoSQL database, it's redacted. Right? So you're not going to see someone's social security number. It's secured. So how does this actually work? Like, what's going on under the covers? Well, effectively, you have data stored in these various sources on the left-hand side, right? Your left, yeah, left-hand side. Whether it's in Hive, it's in NoSQL database, et cetera. What you do is you create external tables in the Oracle database. So we're not moving data. We're just creating external tables that will be pointing to data that's stored in those remote sources. Okay? And as you create these tables, it's going to inherit. It's very easy to create because we'll inherit the metadata from those sources. Right? So if you look at Hive, Hive has a metadata store, and it says, here's the name of the table, here's the columns, here's the data types, here's where the data is stored, here's how you parse that data. All of that's captured in the metadata, and the database will just inherit that metadata. So the creation of these tables is a snap, right? It takes seconds. So now you have easy access to data that's stored in these underlying sources. At which point you can now apply the Oracle SQL dialect to that table, right? So not the minimal SQL dialect, but everything. So if you want to do discovery, and if you want to do analysis, if you want to apply data mining functions, if you want to use windowing functions and advanced statistics and correlations and whatnot, you want full support for all join types and all subqueries. Everything that's been used by 300,000 Oracle customers today, you got that, right? It'll just work on data regardless of where it's stored. So now when you want to find that double bottom in the W, it's just a query, right? So we have pattern matching. It's just a query. It's a select statement. So instead of writing hundreds of lines of Java code to answer that question, you write a dozen lines in a select statement. And you're now easily able to find the double bottom, right? For example, that's just one of many analytic functions that you have available to you. So the full breadth of Oracle SQL, rich Oracle SQL, regardless of where that data may be stored. So how it works under the covers is, let's say I have a query that's spanning multiple sources, right? So I'm sure it's hard to see, but on the far left, you have data that's stored in the Oracle database, and I'm joining that with data that's in HDFS, the Hadoop distributed file system, with data that's stored, let's say, in the Oracle NoSQL database. Right, so you have that one query, and what's going to happen is Oracle will now process that query in parallel across those clusters. Right, so it's going to process it close to the data. So just like we do it in Exadata at the storage tier, we push the processing to your Hadoop cluster, and we're going to process that data locally on that Hadoop cluster. And on your NoSQL database cluster, we're going to do the same thing, right? Process all that data locally. So in this massively parallel query across all of your data. Just like in Exadata, where you have storage indexes, if you have 100 terabytes, well, we have indexes. So you may only need to scan 100 gigabytes of that data to actually come up with your result. So you get fast scans of all of your data. It pushes the filtering locally. So basically, let's say you're querying 100 terabytes of data and we want 5 rows. 5 rows come back, right? So you get fast query performance. You minimize data movement. You process data locally. We've learned a lot about processing data locally. We've been doing it for a while, and it's been extremely successful. So that's basically what we're doing, right? We're going to give you the full power of Oracle SQL, of all of that analytics over all of your data, regardless of where it may live. Whether it's in NoSQL, whether it's in HDFS or available through Hive, or it's in the Oracle database. So now you can leverage all of that data, and you can leverage the security of the Oracle data, the Oracle database, whether you're doing row-level security, redaction, data masking. All of that applies, regardless of where that data may live. And you'll get the fastest performance because we're going to be processing all that data in parallel across all those different clusters. So really leveraging the power of these new platforms. And importantly, there's no changes to the applications that you've developed. Your applications will just work. Just like when you ran that query in 1974, you can run that today over your Hadoop cluster, and it'll just work. And that's pretty nice for our customers. You really get to leverage your skill sets and leverage your investment. So as you saw in that video in the front, my 30-second video, we're going to have a big announcement on July 15th about what this new product is going to be. So if you go to oracle.com/bigdatabreakthrough, you can find out more, or oracle.com/bigdata, and you can register for the event. And again, so I think Sandra pointed this out as well. There's other Oracle talks going on for across the Cloud Expo. So I think our next one's at 2:50. Plug into the cloud. Your blueprint to database as a service. So anyway, that's what we're up to at Oracle in trying to unify your data platforms and have fast query access to all your, or SQL access to all your data. So if you have any questions, come grab me, and just thank you very much for your time.